Hello, Luke. Welcome to lesson 98. So today we're going to be talking about the distance between 2 points and the slope formula. The distance between 2 points topic, we'll be working with the Pythagorean theorem. So if you remember in a previous lesson, we talked about triangles. And recall that in particular, we talked about right triangles. All right? And remember we said that if you have a right triangle and you have obviously the three sides to the triangle, and let's say you know the length of two of those sides, can you find the length of the third side? And remember the all-important Pythagorean theorem, which said that yes, there is a relationship between the sides, and it can be expressed in the formula a squared plus b squared equals c squared. Right? This is just review. So if I know any two of these sides, I can solve for the other side using the Pythagorean theorem. All right? Now recall the only thing that we need to remember is which side is which. Now A and B, we can really write those either way. This side could be A or it could be B. This side could be B or it could be A. The important one is the C. The C has to be, remember, the hypotenuse. All right? Which basically means it's the longest line that's connecting the two shorter lines that are the legs of the 90-degree angle. All right, so find your 90-degree angle. The two lines connecting that 90-degree angle, those are your A's and your B's. The C is always the opposite of those. All right, don't get those confused, because if you let's say you're given a couple of lines, or let's say you're given the length of A is 3, excuse me, and let's say that the length of C is equal to 6, and you're trying to find the length of B. All right, what is the length of B? Well, you have to recognize that they've given us the C and they've given us the A. All right, and that C is on the one side of the equation. Here's our C. So we can plug the C in as a 6, and we can plug the A in as a 3, and the B, of course, is the unknown. The key is we have to set it up this way. I could not set it up like this. Let's say I just thought, oh, I'll label this A, and I'll label this B, and I'll label this C. And in which case I would have A would mean 6 squared in this case, plus the B, which we say is 3, so actually I'll mark that as a 3 squared, equals the C, which is the unknown here, and we get C squared here to complete our formula. But notice the big difference here. These two equations are not the same. Here we have the 6 squared and the 3 squared, the knowns, they're all on the left side of the equation. In this first equation, we have two knowns again. We have the 3 squared and the 6 squared, but they're on opposite sides of the equation. So these two are very different from each other. All right, so you really need to keep track of where is the hypotenuse. Where is this line here? Okay, and remember to label that as C. And the other two, it doesn't really matter which is which, but they're going to be A and B. All right, so make sure you have that straight in your head. But the goal here is just to review and recall how to use the Pythagorean theorem. All right, if we know any two sides, we can find the third side with this formula. All right, now let's take that one step further and let's look at some graphing. So let's say I have a couple points. Let's say I have a point right here. Okay, what are the coordinates for this point? Can you tell me? They would be the x coordinate comes first, so that would be a 4, right? And the y coordinate would be a 3. So the coordinates are 4, 3. All right? Let's say I have another point. Let's put it right over here. This one is what? What are the coordinates for this point? Well, it's a -2 for the x, right? And then another -2 for the y. So we have -2, -2. All right. Now let's say that I am interested in finding the length of the line that would connect these 2 points. So I'm asking you, what's the length of this line? Well, you might say, I don't know. I can't use a ruler on it. Well, There is a way to figure it out, and it's, lo and behold, by using the Pythagorean theorem. So what we're going to do is we will kind of do what we did in a previous lesson when we were looking at the slope. If I asked you to find the slope of this line, recall that you would kind of take, one known point such as this one, and that's not quite in the right spot, and we would continue this down to about here, and then we would run this one directly over like this, right? We'd kind of draw this triangle, and because we're looking for the slope, recall that slope is simply the rise over the run, which in this case we have, what's the rise? The rise would extend from here up to here. And how many units is that? Well, that's 1, 2, 3, 4, 5 units. So the rise is 5. And the run is 1, 2, 3, 4, 5, 6. 5, 6, right? So remember, we could say that the slope of this line is 5 over 6. All right. Now, what I want to know, though, is what is the length of this line? What is the length? Which is a completely different question. But we are going to take some of the same steps. So when we try to find the length, the first thing to do is to do exactly what we did when we found the slope. Draw this triangle that would connect the two dots, right, into this triangle shape. And then what we're going to do is we're going to look at the lengths of these two sides. These two sides are easy to see the lengths on. The rise is the 5, right, which is what we measured before when we asked how high did it go. Well, it's 5 units high. All right, what's the run? Well, we found that when we found the slope. The run was 6. All right, it's 6 units long. All right, so basically what we've done here is we've created a triangle that is a right triangle. That's important. This is a right triangle. And we know 2 of the sides. We know that one side is 5 and the other side is 6. So if we're trying to find the length, what would be this side? That's what we're looking for. And notice that the Pythagorean theorem falls perfectly into this problem. So if the Pythagorean theorem says that a squared plus b squared equals c squared, all we need to do is make sure we label correctly what's our a, what's our b, and what's our c. All right, so here's our 90 degree. Remember, the a and b are the lines that are connecting the 90 degree. So we'll call this side, a, and we'll call this side b. And that would mean this side is our c. All right, so let's plug that in. What is a squared? Well, a is a 6. So 6 squared is 36. Our b is a 5. What's 5 squared? 5 squared is 25. Equals c squared. That's the unknown. That's what we're trying to find, the length of that side. And now we have an equation in one unknown that we can solve. So 36 plus 25 is 61 equals c squared. And recall how we do this. We can take the square root of both sides. So if I take the square root of this side, it's going to give me a c. And if I take the square root of this side, remember this is going to have to be a plus or minus square root. The plus or minus square root of 61, it can't be reduced. So it is a plus or minus 61. That's just as far as we can go. Now, because we're talking length, we're only interested in the positive solution. It doesn't make sense to say that the length of side C is negative square root of 61. It would only make sense to use the positive. So we will say that the length of side C, the length of that line that goes to the 2 points, that connects the 2 points, is going to equal the square root of 61. And that is our solution. All right? So hopefully that's pretty clear to you. It's actually pretty cool when you really look at it. We're able to use that Pythagorean theorem, which maybe didn't look that interesting, but now you can take any 2 points on a graph and actually find the distance between those 2 points by using the Pythagorean theorem. All right? So let's try one here. Find the distance between the points -4, -5, and 5 and 3. Why don't you go ahead and pause the video? I know maybe you don't have a piece of graph paper down in front of you, but if you can, try to rough it in. and try to do this on your own and see what you come up with. And then we'll do it together and see how well you did. All right, so the first step is to, again, like I said, get a piece of scratch paper and put a graph down. All right, or if you have graphing paper, that works well also. So once we have our graph kind of laid out, let's write in the points. So we have the coordinates -4, -5. That's point number 1. So -4 on the x would put us here. -5 down would put us right here. So that's our first point. Okay, and then our second point is 5, 3. So 5 on our x, 3 up on our y. That puts us right here. All right, and again, what's the goal? The goal is trying to connect this dot to this dot and then finding out what's the length of this line. And clearly that would be very difficult to do just based on looking at our squares, our grid. All right, so what do we do next? Well, next we're going to do what we did before, which is we're going to draw our triangle. So we'll start at this point and we're going to come down until we're in line with the bottom point, which would be right about there. And then we'll start on this point and we'll come across to make our corner of the triangle. And notice again that this is indeed a right triangle. And by the way, it wouldn't matter which direction you went. I mean, I went down to make this triangle. If I had wanted to, I could have done this differently. I could have started on this point, maybe gone up, and made my triangle look like this. Oops, that's crooked. So starting here, I go up to here, and then I go across like this. So notice I just made another triangle. It's just kind of upside down. Here's our 90 degree. Whoop. Here's our 90 degree. Right? So we still have a 90 degree triangle. Either one of these triangles would work. We can use the orange one or we can use the green one. They'll both give us the same thing. That's important to recognize. All right, so no worries on how you draw that triangle. All right, so now let's find the lengths of the sides. And again, we could do the green triangle or the orange. Let's do the green since we did one that was more like the orange on the last one. So let's look at the sides. Where are our sides? This is going to be side A, we'll call it. This will be side B, we'll call it. And this is side C, the hypotenuse, connecting those two, right? Make sure you've got that in the right spot. Okay, now we can look at what are the lengths. So the A is 1, 2, 3, 4, 5, 6, 7, 8, 9. A is equal to 9. B is equal to 1, 2, 3, 4, 5, 6, 7, 8. So B is equal to 8. Okay? And now we have our two sides. We just need to find the hypotenuse side. So what's our formula? Our formula is a squared plus b squared equals c squared. Now our a, we just found that to be a 9. So 9 squared plus the b, we found that to be an 8. 8 squared equals c squared. So 9 squared is 81 plus 64. C squared is 145 is equal to c squared. And then we're going to take the square root of both sides. That's going to give me a positive minus square root of 145 is equal to c. Okay, now we could take the 145 and try to reduce it. We can say that 5 can go into that, right? Which can go into what? 29 times, I believe. 29 times. And then 29 actually is in a prime number. Nothing can go into 29 except for itself and 1. So yeah, this is already all the way reduced right here. All right, so the length then, or c, is going to be the square root of 145. Notice we're using just the positive answer. Okay? Excellent. Maybe just real quick, we won't take a lot of time here, but just notice that you would have gotten the same answer if you would have used the orange. If you would have counted up these squares, you would have counted up 1, 2, 3, 4, 5, 6, 7, 8. See, it's still 8. And then this side is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's still 9. So you would have still had, you know, if this is our A, this is our B, you still would have had 8 squared plus 9 squared is equal to c, which is what we have over here. Okay, so clearly it didn't matter which triangle we used. All right, very good. Let's just try one more to make sure that you have it, and then we're going to move on to the second part of our lesson today. So why don't you pause the video, try this one on your own, and then we'll do it together. All right, so for the first step here is to find the points. So we have a -3, -3. So our -3 on the x, down 3 for the y, puts us here. And then we have a 2 and 4. So 2 and then up 4 puts us here. All right, we will connect those two lines like so. And once again, we're going to create a triangle. So we'll start on this one. We'll come down this time to here. And then we come over here and we go across. Okay. And again, this is indeed a 90-degree. So how far did it come down? 1, 2, 3, 4, 5, 6, 7 down. And then over here, it's 1, 2, 3, 4, 5 across. This is the unknown, the hypotenuse, which is the c. So we can plug these in. So a squared plus b squared equals c squared. So 5 squared plus 7 squared is going to be equal to c squared. And that's going to give us 25 plus 49 is equal to c squared. 25 and 49 is what? 74 is equal to c squared. And then once again, we can take the square root of both sides. So we end up with a plus or minus square root of 74 is equal to c. And then 74, I think we can pull something out of there. If we take a 74, and that's going to be 37. Excuse me. Which is, well, actually, that's prime. So, no, there isn't anything we can pull out. It's another one that's completely reduced. So the length, then, of our line, our orange line on the graph, is going to be the square root of 74. There's our answer. All right, very good. Now, let's move on to our second topic for today. And it's somewhat related. It's the slope of a line that passes through 2 points. All right, so we just talked about how to find the length of a line that connects 2 points. Now, we're going to say, well, let's just kind of throw on this graph 2 points. Let's say I throw 1 point here. And let's say well, you know what? We've been going that direction a lot. Let's start with this side this time. Let's say we have a point here. And let's say I have a point, oh, I don't know, here. Well, that might be a little bit easy. Let's go here. All right. Okay. And then what we might ask is, okay, here's 2 points. Let's label them. This is point, on the x, it's a -4, -4. And then on the y, it's a +4. And then this point down here is a 2 on the x, right? And then a -4 on the y. So there we go. And then let's say we've got a line that runs through these. Something like that. Okay? And now, let's say I want to find the slope for this. Now, as you've learned in the past, and we just mentioned this, to find the slope of these lines, generally we did what we just did a minute ago. We would take these points, you know, it wouldn't have to be these points. We could also try to find any spot on this line where there's a nice location. In this case, the nice locations look to be like they're only on the points. So we'll take this first location here, and we essentially create the same triangle that we created with the last problems. Okay, nothing really new going on here. And then we found the slope of that by just looking at what the rise and the run was. So what's the rise? It's 1, 2, 3, 4, 5, 6, 7, 8. Whoops. Make that right, 8. And then what's the run? 1, 2, 3, 4, 5, 6. The run is 6. And so the slope of this line is going to be a negative. Now don't forget, it's a negative because we're going downhill, right? The green line is going downhill as you look at it from left to right. You know, the little man walking over here, if he's walking down this hill or this line, he's going to be walking downhill. All right, so because of that, we have a negative slope. And then the rise over the run. So the rise is 8. The run is 6. This can be reduced to a negative 4/3. So this is our slope. We might also call it the m, right? Because remember our formula, y equals mx plus b for a line. The m is the slope. Okay? So that's how we've been finding slope up to this point. However, there's actually a nice little formula that we can use to find the slope when we've been given 2 points. All right? And the beauty of this is if we've been given 2 points, we don't even need to graph it. We can just use a formula to get to the slope without doing any graphing. It's pretty cool. All right, so how could we do it? Well, let's think about what's going on here. All right, if this rise is 8 and this run is 6, what we might want to do is think of the rise as being the change in y. The change in y. Remember, y is going up and down. So from this point to this point, this is the change in y. That's what the rise is. Maybe I'll even write that over here. The rise is equal to the change in y. And then what's the x? Well, the x is equal to the change in, or not the x, I'm sorry, the run. The run is equal to the change in x. So what's the run? It's equal to the change in x. Okay? That's kind of the formal definition of those two, rise and run. Now, if we think about it, when we are given 2 points, these points, the coordinates of these points, represent changes in y and x. They're a location. They're a location of an x and a y coordinate. So when we're when we're given a set of points, the thing to remember is the first number is the x, the second number is the y, and I know you know this. All right? But if our first point has an x and a y, so I'm going to call this x1, x sub 1, and y sub 1. And then we have a second point, and our second point is going to be x sub 2 and y sub 2. This is just so we can differentiate between the first and the second point. All right, so if we're given these 2 sets of points, then how could we find the rise, the change in y? Well, couldn't we just take the 2 y's, take this y and this y, and subtract them from each other? Wouldn't that give us a change in y, the change, the difference in the y's? Sure. So we could think of it as being the rise is equal to the change in y. So it'd be y1 sub 1 minus y sub 2. Okay? That's what the rise is. What's the run? Well, in a similar way, the run is the change in x. So here's our first x. Here's our second x. How do I know what the change is between those two? We can subtract them to find that. The change in x is x sub 1 minus x sub 2. Okay? So this is in general here. I'm not actually using specific numbers. I'm just using x's and y's. But do you see how this would happen? The rise is the change in y. It's just the difference between the two. The run is the difference between the x's. And if I want to know what my slope is then, my slope is going to be the rise over the run. Well, here's the rise, which is this. So the rise is y sub 1 minus y sub 2 over the run, which is this. So it'll be x sub 1 minus x sub 2. So I end up with this formula. All right? The formula to find the slope given 2 points is simply the first y minus the second y, the first x minus the second x. And that'll give us the slope. And to show how that would work here, let's try this formula out and see if it works. So in this particular case, if I want to know what y1 is, let's say this one right here is going to be our first point. What's our y? Now be careful. Remember how these are organized. The first is the x1, and this would be our y1. So the y1 is a 4, right? So we have a y1. Oh, maybe I'll just put it here. Well, let's say I'm running out of room here. Let's put it over here again. So the formula is y1 minus y2 over x1 minus x2. And what's the y1? We said the y1 is 4. Well, what's the y2? The y2, we have to go to the second point over here. What's the y2? It's this negative 4. That's the y, right? Now remember, we're subtracting this. So y1 is 4. Then we have our subtraction sign. Then we have the y2, which happens to be a negative. So do you see how I have two negatives here? One negative came from the formula, and the other negative is because it is a negative coordinate. All right, so 4 minus a minus 4. In the denominator, we have our x's. So our x's are a negative 4 for the first point, and we're going to subtract, because that's what the formula says, so we're going to subtract the second x, which is a positive 2. All right, so now we just have to simplify this little bit of a mess here. So 4 minus a minus 4 would be 4 plus a 4, which is going to be 8. And then negative 4 minus 2 is going to be a negative 6, right? I'm going to put the negative out here. Negative 6. All right. Then we can now take if we reduce this, we have a negative 4/3, which lo and behold is the exact same slope that we came up with up here. All right. Is that cool or what? We just solved it completely by using this formula. We don't even need to graph it. Graphing is always nice to see the picture, but if they had just given us these 2 points, we could have found the slope for the line. Okay? All right. So, in your class notebook, let's write this down so that we don't forget it. The slope of a line through 2 points formula. And it says, given P1, P sub 1. P sub 1 is simply the first point. So given P sub 1 is equal to x sub 1, y sub 1. And P sub 2, meaning the second point, is x sub 2, y sub 2. All right. The line that passes through these points has the slope, and this is the important part. The formula is m, which stands for slope, equals y2 minus y1 and x2 minus x1. All right. Now I think, just so you're not confused, I put it over here as y1 minus y2. That's okay. It doesn't matter which one you actually write first, so long as they're the same in the numerator and in the denominator. So if you were to write this as y sub 1 minus y sub 2, that's fine. But then you'd have to write this as x sub 1 minus x sub 2 in the denominator. So they need to be in the same order, but the order doesn't really matter as long as they're the same. Okay? All right. Very good. So let's try some now. And here, I'm not going to give you the graph. I'm just going to give you the points. So it says, find the slope of the line that passes through the points -3 and 4 and 5 and -2. Now, we could graph this off to the side if we wanted to, but now we're just going to use the formula, the slope formula for the line that passes between 2 points. These are our 2 points. So we have point number 1 right here, and then we have point number 2 right here. Okay, maybe I'll just put that. This is P sub 2. This is P sub 1. Okay? All right, so what is the formula? Well, the formula is, maybe I'll say M for slope. M is equal to y sub 2 minus y sub 1. Remember, the y's are on top. And then x sub 2 minus x sub 1. Whoops. I guess I didn't need to put those in parentheses, actually. Not sure why I did that. We'll clean it up here a bit. Okay, so there is our formula. Now we just need to plug things in. So this is going to equal, what's the y sub 2? Well, y sub 2 is the y from the second point. Well, here's our second point, That's why we labeled it p sub 2. And the y for that is right here, right? The negative 2. So we will write a negative 2 in for our y sub 2 here. Then we have our minus sign. Don't forget to write this minus sign down. Don't lose it. Minus sign, and then what's the y sub 1? So here we have to look at the first point and look at its y. Its y is going to be here, the 4. So we have minus 4. That is going to be over our x's. Now what are our x's? Our x's are from the first numbers. And from the first point, it's going to be a negative 3. So we have a negative 3. That's for x. Oh, excuse me. I'm sorry. We're supposed to be doing x sub 2. So x sub 2 is over here, the second point, which is a 5. And then we subtract x sub 1. So we subtract, what is x sub 1? X from the first point is going to be a negative 3. Watch out again. We have another one of those double negatives here. All right. This is going to equal what? Well, we're going to have negative 2 and a negative 4 is a negative 6. 5 plus 3 is going to be an 8, which is going to give me a negative. Notice again, I'm just moving this negative out in front. And if I reduce the 6/8, I'd get negative 3/4. So that is my slope. Okay? It's a thing of beauty. All right, let's try another one. Try this one on your own. Pause the video, and then we'll do it together. All right, so how did you do? Well, let's try it. So the first one, this is p sub 1. Point number 1. And then we'll have point number 2 over here. Okay? What's the formula? Let's always write that down. That helps us memorize it. Well, actually, let's make this black. So we have m is equal to y sub 2 minus y sub 1 over x sub 2 minus x. Excuse me. Oh, my goodness. There. X sub 2 minus x sub 1. Okay. So there we have it. There is our formula. Now we just need to plug things in. So this is going to equal, well, let's see what we've got. So point number 1, or excuse me, point number 2. Point number 2 is the blue, and we're finding the y for that. So this would be y sub 2, the y from the second point. And that's going to be a negative 4. Okay? Minus the y from the first point, y sub 1. Well, what's that? That's going to be this guy right here, right? So minus a minus 1. Okay. Then we've got in our denominator x sub 2. So x sub 2 is going to be from the second point, the x, which is a negative 4. We're going to subtract from that the x from the first point, which is this one, the negative 1. So we have again another double negative. And it looks like this. Very similar, right? Because the points were basically just doubled up. If we then reduce this, or I should say simplify it, we have negative 4 plus 1 is going to be a negative 3. Negative 4 plus 1 is going to be a negative 3. Negative 3 over negative 3 is a 1. So the slope here is simply a 1. All right? Excellent. Very good. So I hope that makes sense to you. Overall, it's kind of a fun lesson. We're really just dealing with two very important formulas. One is the formula for the slope given 2 points, which is this one. Make sure it's in your class notebook. And then the other one that we've already learned in the past was our Pythagorean theorem. Remember, we use that to find the length of the line, and we use this formula, slope formula, to find the slope of a line. All right? Very good. So we will stop here. Good luck with your seat work, and I will see you tomorrow.